The question is to find local minimums and maximums of a square root function by using derivatives and critical points to identify extrema coordinates. Typically, this problem is at the level of a calculus assignment or quiz. If you're preparing for final exam level calculus questions, feel free to check out my YouTube videos linked above. You're given a function named g of x, which equals x minus 10 times the square root of x. Our task is to identify all local maximum or local minimum points for this function. Please state the coordinates of any local extrema and explain your answer using calculus reasoning. We begin with the function g of x equals x minus 10 times the square root of x. Let's rewrite it for easier differentiation. That becomes x minus 10 times x raised to the 1/2 power. First, we'll find the derivative of g of x. The derivative of x is 1. The derivative of 10 times x to the 1/2 is 10 times 1/2 times x to the negative 1/2. That simplifies to 5 divided by the square root of x. So, the derivative of g of x becomes 1 minus 5 over the square root of x. Now, let's write that in a single fraction. That gives you s, the square root of x minus 5, all over the square root of x. Next, we find critical points. To do that, we set the derivative equal to 0. That means the numerator, which is the square root of x minus 5, must be 0. Solving that gives us square root of x equals 5. So, x equals 25. We also need to check where the derivative is undefined. That happens when the denominator, which is the square root of x, equals 0. So x equals 0 is another critical point. Now we have two values to consider, x equals 0 and x equals 25. Next step, test values on each side of x equals 25 to see where the function is increasing or decreasing. Pick a number less than 25. Let's say x equals 1. Then the derivative becomes 1 minus 5 over the square root of 1, which is 1 minus 5. That gives negative 4. Since the derivative is negative, the function is decreasing before x equals 25. Now, pick a number greater than 25. Let's try x equals 36. The derivative becomes 1 minus 5 over the square root of 36. That's 1 minus 5 over 6, which is a positive number. So the function is increasing after x equals 25. Therefore, the function is decreasing before 25 and increasing after. That means the function reaches a local minimum at x equals 25. To find the y value of this minimum point, plug x equals 25 back into the original function. That gives 25 minus 10 times the square root of 25. The square root of 25 is 5. So that's 25 minus 50, which equals negative 25. Final answer is, there is no local maximum. There's a local minimum at the point where x is 25 and y is negative 25. Here's how you should think about problems like this. Whenever you're looking for local minimums or maximums, your first move is to take the derivative because it tells you how the function changes. Then you set that derivative equal to 0 or c where it's undefined. Those are your critical points. Next, you test values on either side of the critical point. If the function goes from decreasing to increasing, you found a minimum. If it goes from increasing to decreasing, that's a maximum. Finally, always plug the x value back into the original function to find the actual coordinate of the extremum. The question is, that's it for this question. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel. If you're looking for tutoring on final exam level questions, check out my YouTube channel at MathTutor8285. You'll find helpful explanations and strategies to ace your exams.